In this video, we are going to learn about AVL tree. The AVL tree was developed by J.M. Adilson-Wilski and E.M. Landis in 1962 and is named in the honor of investors. An AVL tree is a height-balanced binary search tree where each node has balance factor determined by subtracting the height of its right subtree from the left subtree. A tree is considered balanced if every node's balance factor falls between -1 and 1. If any node's balance factor goes beyond this range, the tree becomes unbalanced and requires adjustments to restore balance. The balance factor of node K is calculated as height of the left subtree minus height of the right subtree of K. If a node's balance factor is 1, it indicates that the left subtree is one level taller than the right subtree. Now let's see the operations of AVL tree. Since an AVL tree is a type of binary search tree, all standard binary search tree operations such as searching and traversing are carried out the same way and do not disrupt the AVL tree's balance properties. However, insertion and deletion operations can disrupt this balance, so they must be carefully managed to restore the AVL tree property when necessary. Insertion in AVL tree is performed in the same way as it is performed in the binary search tree. However, it may lead to violation in AVL tree property and therefore the tree may need balancing. The tree can be balanced by applying rotations. Deletion can also be performed in the same way as it is performed in a binary search tree. Deletion may also disturb the balance of the tree, therefore, various types of rotations are used to rebalance the tree. Now, let us understand why to use an AVL tree. An AVL tree maintains control over the height of the binary search tree, preventing it from becoming skewed. In a binary search tree with height h, the time complexity for operations is big O of h. However, if the tree becomes skewed, in the worst case, this can extend to big O of n by keeping the height around log of n. An AVL tree ensures that each operation has upper bound of big O of log n, where n is the number of nodes. Let us understand the AVL rotations.